Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. So now let's get started on our set of questions for today's session. Okay, so question 1 asks, what is the net ionic equation for the reaction with beryllium chloride with sodium hydroxide? Okay, so step 1 is to just balance the atoms. So typically when you have a compound that reacts with another compound, NaOH, typically a double displacement reaction occurs. So here, the beryllium will now be bonded with the hydroxide. And beryllium has a +2 charge, so that's why we need 2 hydroxide ions to balance that out. And our second product is just sodium chloride. Okay, so before I write down the states, step 2 is to look up the solubility rules. So this will help us figure out whether or not any of these products will precipitate in solution. Okay, so we can use any of these. Okay, so these are the solubility rules. First up, we have beryllium hydroxide. So if we look at the rules, it says all compounds of group 1A ions and ammonium are soluble. So beryllium is not a group 1A ion. All common nitrates, acetates, most perchlorates are soluble. So this is not the case for beryllium hydroxide as well. All common chlorides, bromides, and iodides are soluble. Nope. And all common sulfates are soluble. Okay, so no. Okay, so for the insolubility rules, it says all common metal hydroxides with OH are insoluble. Okay, so this is actually our compound. Beryllium is not a group 1A metal. The larger group 2A ions beginning with 2+, calcium 2+. Okay, so that's not beryllium as well. So we can say that beryllium hydroxide will be a solid when it is produced. In the case of sodium chloride, sodium is a group 1A ion, and we know that it will be soluble, so I put an aqueous. Okay, so now we actually have to make sure that the reaction is balanced in terms of the atoms. So we have 2 chlorines on our reactant side, so I'm going to put a 2 in front of sodium chloride. So now we have 2 sodiums, so I will put another 2 in front of sodium hydroxide. Okay, so now that everything is balanced in terms of the atoms, next we want to separate them into ions. Okay, so typically all of our aqueous reactants and products will separate into their ions, but the solid beryllium hydroxide will stay as it is. Okay, so breaking this up, we get Beryllium-2 plus and 2 chlorine minus ions. We get 2 Na plus ions. And we get 2 OH minus. Our solid stays the same. And then our sodium chloride is dissociated to Na plus and 2 chlorine minus. Okay, so step 4 is to remove your spectator ions. So spectator ions will appear the same for both your reactants and your products. So for example, there are 2 chlorine ions in our reactant side and 2 chlorine ions in our product side, so I can cancel them out. And there are 2 sodium plus ions on our reactant side and also 2 in our product side, so I'm going to cross them out also. And then that brings us to step 5, which is just writing the net ionic equation. So this is everything that was left over. Sorry. Which is the Beryllium-2 plus the 2 OH minus making beryllium hydroxide solid. Okay, so let's see what the junior tutor said. There are several types of equations used in representing a reaction. The first 2 are the molecular and complete ionic equation. A molecular equation is an equation that shows the reactants and products as they are. This differs from the complete ionic equation, which shows species that are strong electrolytes as ions. The molecular and complete ionic equation of the reaction of beryllium chloride and sodium hydroxide are shown in equations 1 and 2. Okay, so they showed how to balance the products. They showed it separating into the ions in equation 2. And a net ionic equation is an equation where only the species that are directly involved in the reaction. That means that the spectator ions, which are ions that do not directly participate in the reaction, are omitted from the reaction. Another way of looking at a net ionic equation is that the ions that are in the reactants and products cancel each other out. The net ionic equation of the reaction is shown in equation 3. Okay, so they have beryllium 2 plus 2 OH minus, making the beryllium hydroxide. Yep, so this solution is correct. Okay.